Hey everyone, this is Reshma from Edureka, and today I'll take you through a very interesting topic that is none other than deep learning. And like most of you, even I'm deeply fascinated with artificial intelligence. Think about this. Instead of you doing all your work, you have a machine to finish it for you, or it can do something which you thought was not possible. For instance, predicting the future, like predicting earthquakes, tsunamis, so that preventive measures can be taken to save lives. Chatbots, virtual personal assistants like Siri in iPhones, Google Assistant, and believe me, it is getting smarter day by day with deep learning. Self-driving cars. It will be a blessing for elderly people and disabled people who find it difficult to drive on their own. And on top of that, it can also avoid a lot of accidents that happen due to human error. Google AI Eye Doctor. So this is a recent initiative by Google where Google is working with an Indian eye care chain to develop an AI software which can examine retina scans to identify a condition called diabetic retinopathy, which can cause blindness. AI music composer. Who thought that we can have an AI music composer using deep learning? And maybe in the coming years, even machines will start winning Grammys. And one of my favorites, a dream reading machine. With so many unrealistic applications of AI and deep learning that we have seen so far, I was wondering that whether we can capture dreams in the form of a video or something. And I wasn't surprised to find out that this was tried in Japan a few years back on 3 test subjects, and they were able to achieve close to 60% accuracy. And that is amazing. But I'm not sure that whether people would want to be a test subject for this or not because it can reveal all your dreams. Great. So this sets the base for you and we are ready to understand what is artificial intelligence. Artificial intelligence is nothing but the capability of a machine to imitate intelligent human behavior. AI is achieved by mimicking a human brain by understanding how it thinks, how it learns, and works while trying to solve a problem. For example, a machine playing chess, or a voice-activated software which helps you with various things in your phone, or a number plate recognition system which captures the number plate of an overspeeding car and processes it to extract the registration number and identify the owner of the car so that he can be charged. And all this wasn't very easy to implement before deep learning. Now let's understand the various subsets of artificial intelligence. So till now you'd have heard a lot about artificial intelligence, machine learning, and deep learning. However, do you know the relationship between all three of them? So deep learning is a subfield of artificial intelligence. So it is a subfield of machine learning, which is a subfield of artificial intelligence. So when we look at something like AlphaGo, it is often portrayed as a big success for deep learning. But it's actually a combination of ideas from several different areas of AI and machine learning like deep learning, reinforcement learning, self-play, etc. And the idea behind deep neural networks is not new, but it dates back to 1950s. However, it became possible to practically implement it only when we had the new high-end resource capability. So I hope that you have understood what is artificial intelligence, so let's explore machine learning followed by its limitations. So machine learning is a subset of artificial intelligence which provide computers with the ability to learn without being explicitly programmed. In machine learning, we do not have to define all the steps or conditions like any other programming application. However, we have to train the machine on a training dataset large enough to create a model which helps the machine to take decisions based on its learning. For example, if we have to determine the species of a flower using machine, then first we need to train the machine using a flower dataset which contains various characteristics of different flowers along with their respective species, as you can see here in the image. We have got the sepal length, sepal width, petal width, and the species of the flower too. So using this input dataset, the machine will create a model which can be used to classify a flower. Next, we will pass on a set of characteristics as input to the model and it will output the name of the flower. And this process of training a machine to create a model and use it for decision making is called machine learning. However, this process had some limitations. Machine learning is not capable of handling high-dimensional data, that is where input and output is large and it is present in multiple dimensions. And handling and processing such a data becomes very complex and resource exhaustive. And this is termed as the curse of dimensionality. So to understand this in simpler terms, let us consider a line of 100 yards. And let us assume that you dropped a coin somewhere in the line. You will easily find the coin by simply walking on the line. A line is a single dimension entity. Now let's consider that you have got a square of side 100 yards each and you dropped a coin somewhere inside the square. Now definitely you'll take more time to find the coin within that square. A square is a two-dimensional entity. Now let's take it a step ahead and consider a cube of side 100 yards each and you dropped a coin somewhere inside the cube. Now it is even more difficult to find the coin. So if we see that the complexity is increasing as the dimensions are increasing, and in real life the high dimensional data that we're talking about has got many dimensions, which makes it very, very complex to handle and process. The high dimensional data can be easily found in use cases like image processing, natural language processing, image translation, etc. And machine learning was not capable of solving these use cases, and hence deep learning came to the rescue. So deep learning is capable of handling the high dimensional data and is also efficient in focusing on the right features on its own. And this process is called feature extraction. Now let's try and understand how deep learning works. So in an attempt to re-engineer a human brain, deep learning studies the basic unit of a brain called a brain cell or a neuron. And inspired from a neuron, an artificial neuron or a perceptron was developed. So if we focus on the structure of a biological neuron, it has got dendrites. And these are used to receive inputs, and these inputs are summed up inside the cell body, and using the axon, it is passed on to the next biological neuron. So similarly, a perceptron receives multiple inputs, applies various transformations and functions, and provides an output. As we know that our brain consists of multiple connected neurons called neural network, we can also have a network of artificial neurons called perceptrons to form a deep neural network. Let's understand how a deep neural network looks like. So any deep neural network will consist of three types of layers: the input layer, the hidden layer, and the output layer. So if you see in the diagram, the first layer is the input layer, which receives all the inputs. The last layer is the output layer, which gives the desired output. And all the layers in between these layers are called hidden layers. And there can be n number of hidden layers thanks to the high-end resources available these days. And the number of hidden layers and the number of perceptrons in each layer will be entirely dependent on the use case that you're trying to solve. And there is mechanics to decide the number of hidden layers. However, we'll not get into that in this session. Now, since you have a picture of deep neural network, let's try to get a high-level view of how deep neural network solves a problem. For example, we want to perform image recognition using deep networks. So we'll have to pass this high-dimensional data to the input layer. And to match the dimensionality of the input data, the input layer will contain multiple sublayers of perceptrons so that it can consume the entire input. And the output received from the input layer will contain patterns and will only be able to identify the edges and images based on the contrast levels. And this output will be fed to hidden layer 1, where it will be able to identify various face features like eyes, nose, ears, etc. Now this will be fed to hidden layer 2, where it will be able to form the entire faces and sent to the output layer to be classified and given a name. Now think, if any of these layers is missing or the neural network is not deep enough, then what will happen? Simple. We'll not be able to accurately identify the images. And this is the very reason why these use cases did not have a solution all these years prior to deep learning. So just to take this further, we'll try to apply deep network on an MNIST dataset. So the MNIST dataset consists of 60,000 training samples and 10,000 testing samples of handwritten digit images. And the task here is to train a model which can accurately identify the digit present on the image. And to solve this use case, a deep network will be created with multiple hidden layers to process all the 60,000 images pixel by pixel, and finally will receive an output. So the output will be an array of index 0 to 9, where each index corresponds to the respective digit. So index 0 contains the probability of 0 being the digit present on the input image. Similarly, index 2, which has a value of 0.1, actually represents the probability of 2 being the digit present on the input image. So if we see that the highest probability in this array is 0.8, which is present at 7 index of the array. Hence, the number present on the image will be 7. So this is how the handwritten image processing happens. Let me practically execute this use case for you. So this is my PyCharm IDE. First of all, let me show you the dataset. So this is my MNIST dataset, and it has got 4 GZ files which gets extracted when my program gets executed. Now the program, or the deep neural network using which I was able to create a model to process all these images and train my machine, is this create model underscore 2.py. And it's a good lengthy program. So I'll not be explaining the entire program for you, but let me tell you the technology or the framework with which I was able to implement this. So I've been using TensorFlow, which is one of the open source Google libraries for deep learning. And right here I have imported TensorFlow, and then I'm using this MNIST data and finally going ahead and creating a deep neural network. So these all things are here. It is creating a deep neural network and the hidden layer that is required to process all these images. And finally, I'm creating a model and I'm saving this model with this name right here, model2.ckpt. Now, if I run this code, it is going to take a very long time. So give it some time. It has extracted all the files and it has started its training. It is at step 0 now. So in order to completely train this model, it is going to take 20,000 steps. Let me show you in the program as well. So here it is. So in here I've set the steps to 20,000, but you can always configure it to a number that is 1,000, 2,000. However, you'll have to run this code for n number of times so that you can achieve a particular accuracy. So after executing for 20,000 times, what happens is a model is created with an accuracy of 92%. So what does it mean? It means that if you pass a particular image, out of 100 images of the model, 92 predictions will be correct. 92 of times, this model will be able to tell you the exact number that is present on the image. Let's not wait for this program to execute completely, otherwise we have to wait for hours. So I've already executed it once and the model is already created. So what is a model? A model is nothing but a set of files, and these 3 files along with the checkpoint files. Now there's another code which is predict underscore 2.py, in which I'm restoring the model. Let me show you the line where I'm restoring it. So it's right here, saver.restore model2.ckpt. So this is the name of my model. So I'm restoring my entire model that was created after training of 20,000 steps on MNIST dataset, and I'm passing an image that is 7_o.png. So it is in this folder. In the test folders, I've got other images and I've got here 7_o. Now this is an image, it's the name of the image. I'm not telling the program what is the number. So I'll just stop this training now. And now I'll execute the prediction part where I'm restoring the model, and this model will tell me the number, the handwritten number that is there in the image. So this was the image 7_o, and the prediction for this image is 7. So my model was accurately able to identify or predict the number that was there on the handwritten image. So let me change the image now. And let me execute this again just to show you the image. Alright, there's one good question that I would like to take. So Akhil asked that how are you saving the weight for the neural net? Can you show us? Sure, Akhil. So in the previous file that I executed, I showed you that I'm using an object called saver. And using the saver object, I can save the entire model, and weights are also automatically saved along with this model in the checkpoint file. So using checkpoint, we can actually reach the final state of the training, and then we can use the prediction model. I hope that is fine. All right. So if you see this 7, this is a handwritten image. This is somebody who writes 7 like this with a strike in between. And now I'm passing a different image of 7. It's 7_1. So it's different from the first one. And I'll run this code again. Now this time the 7 is different, and my machine learning model should be able to predict that this is a 7. Because people write 7 in different ways. Somebody likes 7 like this, somebody writes 7 and makes it look like a 1. They make the top part very small. So there are different ways of writing 7. So however, a machine learning model should be capable enough to find out that as well. So let me just close this and see the prediction. Our model was able to predict the 7 as well and predict the value is 7 as well. So let me execute it again for you. So both the 7s were different, but still the prediction is correct for both of them. So now let us go back to our presentation. So after the MNIST application, let me show you a few more applications of deep learning. The very first is face recognition. Let me give you an example. So all of you are using Facebook and you do spend some time on it. So if you remember a few years back when you used to upload pictures with your friends, it makes a box around a human face with a box appearing at the bottom to ask you to type the name of the person to tag him. So it was able to identify that it was a human face, but now it is able to auto tag. It is not only able to detect faces but also identify who it is. And how is this possible? It is only possible using deep learning. And Facebook also has a deep learning library called Caffe2, using which they have applied all these things. The next use case that is implemented using deep learning is Google Lens. This is one of those applications that has been recently launched for smartphones by Google. What does this app do? You just have to install it, open it, point your camera on a particular thing, like this flower over here, and in real time image processing happens and Google will get back with the entire details of the object, like the name of the flower, where it is found, etc., etc. So if you point it at a building or any shop, it will tell you what kind of a store it is. If it's a restaurant, it will show you reviews, the ratings, menu, etc. So what is happening here is that in real time you are able to use a deep learning net and get all the information you want. And these applications are really amazing because it directly brings deep learning to the end users or the common people. So they can easily use the benefits of deep learning without worrying about what is happening at the background. The next use case is the machine translation. This is again a very important use case. And there is also an app in Play Store and this is called the Translation app. So here is an image that says more chocolate. I don't know what it means. I don't even know which language it is. But with this app, what you can do is that you can capture the picture of the packet and this app will first detect the text in the image, then extract the text like this and then translate it for you. So for example, it has detected the text, extracted it like this, and here it has translated more, which means dark. And then it writes back again on the image. So what is happening in this particular use case is that first an image is captured, image processing takes place, text is extracted through processing, and once we have the text, we translate it to the desired language, which is English in this case, and then again image processing happens where we are writing the text on an image again. So more chocolate means dark chocolate. So this is a really great use case because this is a combination of multiple learning algorithms like CNN and RNN. So these were a few more applications of deep learning. I hope that you have found them interesting. So let us see what we have learned in today's session. At first, we have understood why artificial intelligence because of its wide variety of applications. Then we've understood what is exactly artificial intelligence and the various subsets of artificial intelligence, which are machine learning and deep learning. Then we went through machine learning and understood how deep learning solves all the machine learning limitations. We saw how deep learning works, and in the end, we learned some very interesting applications of deep learning. I hope that you have enjoyed this session on artificial intelligence and deep learning. Thank you for attending this session, and I'll see you next time. Till then, happy learning.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!